What is an antiderivative? Well, think back in algebra, we learned how to multiply two factors, like x plus 5 times the binomial x minus 3, and we would get a product like x squared plus 2x minus 15. Then later we learned how to go in reverse and take a product like the trinomial x squared minus 7x plus 12 and factor it into two binomial factors, x minus 3 times x minus 4. Well, in calculus, we have been learning how to find the derivative of a function, and now we're going to reverse it and find the antiderivative, which is the function capital F, whose derivative is the given function little f. In other words, the function lowercase f of x is actually a derivative of another function capital F. So we want to determine the antiderivative for the following functions. So for this first function, we have f of x equals 1 over x. So that's the same thing as saying capital F prime of x is 1 over x, and we want to find capital F of x. In other words, the antiderivative, the original function. So what is the original function whose derivative is the reciprocal of its argument? Natural log. So we can say the natural log of x, but notice we're putting x in the absolute value. When taking the antiderivative, we must have absolute values for logs. That is because in the derivative function, we only have 1 over x. So the only restriction was that x could not be 0. But with natural logs, remember we cannot take the natural log of negative numbers. They must be greater than 0. Since x could be negative, we must use the absolute value for natural log with the antiderivative. The second thing is, remember the derivative of a constant is 0. So this antiderivative function, or the original function, might have had some constant. And I will be honest with you, that is the one piece I often forget when writing antiderivatives. So keep an eye out for me. Looking at example B, we have a derivative of 1 over x to the 5th. Just like it's easier to take the derivative with it in the form of x to the negative 5th, it's also easier to take the antiderivative. So let's recall when we try to take the derivative of some power function, we first multiply by its exponent, and then we subtract 1 from the exponent. So when we take the antiderivative, we're going to go backwards and do the opposite. So we're first going to add 1 to the exponent, and then we're going to divide by that new exponent. So let's add 1 to the exponent. The understood coefficient was 1, and so we're going to divide by that new exponent. And when we simplify, we're going to get a negative 1/4 x to the negative 4th. This is the answer we're looking for. But we can always check to make sure that we get the original function back. Negative 1/4 times the exponent of negative 4, and then the exponent of negative 4 minus 1. That's going to give us a positive 1x to the negative 5th, which is in fact the function we started with. But what did I forget? I told you. Plus c. There might be some constant. Don't forget the plus c. All right, let's go ahead and try part C. If you want to try it on your own, go for it. This is a good practice one. Pause the video. Otherwise, to get the antiderivative, we are going to add 1 to the exponent and then divide the coefficient by that new exponent. And we will get an antiderivative of x to the 9th. Now, D can be a little trickier. Again, we want to rewrite it as 7 times x to the 2/3. And the tricky part isn't finding the antiderivative, it's going to be reducing that antiderivative. Let's add 1 to the exponent. So 2/3 plus 3/3, that's a 1, that will give us a 5/3. And then we have to divide that 7 by that 5/3. And that's going to give us a 21 over 5 times x to the 5/3. Okay, let's do a little bit of scrap work here. That 7 divided by 5/3 is the same thing as 7 longhand divided by 5/3, which is 7 times 3/5. And that 7 is understood to be over 1. That's where we're getting the 21/5. But now we've got x to the 5/3. That's not reduced. In other words, if I rewrote that x to the 5/3 as the cubed root of x to the 5th, I have 5 x's under here. I only need 3 to have a perfect cube, so we need to simplify that. So we can take that x to the 5/3 and write that exponent as a mixed fraction. In other words, 3 divides into 5 one whole time, has a remainder of 2. So we get 1 and 2/5. That x to the first means we get an x to the first that comes out. Oh, sorry, not 2/5, 2/3, my bad. There we go. We have 1x that comes out, but we're left with that cubed root of x squared. So our final result is going to be 21/5 x times the cubed root of x squared. That is our antiderivative. And what have I forgotten on both C and D? Plus C and plus C. You can see where my nemesis is with these antiderivatives. We all have them.